In late July 2026, a massive monsoon cloud band stretching 10,000 kilometers blanketed 95% of the Indian subcontinent. Current risk models show flash flood warnings heavily concentrated across Jammu, Kashmir, and the northern plains. On the ground, the results are immediate. Urban centers have slowed to a crawl as pedestrians spend hours wading through waist-deep water on major commercial streets. When a storm system dumps a month's worth of rain in just a few days, it masks the reality of India's broader water crisis. This chart of historical rainfall tells a different story. Just weeks ago, India recorded its fifth driest June in over a century, a 40% moisture deficit. That deficit left agricultural soil baked into hardened clay and dropped water levels in major reservoirs to critical lows. The nation is caught between two physical realities: surface flooding that paralyzes cities, and a water table that remains parched after a record dry start to the season. To understand why this rainfall is behaving so erratically, meteorological teams are using data from ISRO's INSAT weather satellites, orbiting 36,000 kilometers above the equator. One key metric is cloud top brightness temperature. As thunderclouds grow taller, their tops become colder, revealing storm intensity. In this event, satellites recorded temperatures below -80 degrees Celsius, indicating clouds pushing 16 kilometers high, leading to massive localized rain dumps. This thermal data confirms the monsoon has concentrated its energy into localized, violent bursts, rather than providing the steady, widespread moisture the region requires. This shift is driven by an intensifying El Niño and global warming, which are altering how the monsoon moves across the subcontinent. As the air warms, it acts like a giant sponge. It absorbs moisture from the ocean and holds it aloft, creating an atmospheric lid that keeps humidity high but prevents clouds from raining. Eventually, the atmosphere becomes oversaturated. When that lid finally breaks, it dumps weeks of stored water onto the landscape in mere hours. However, when that volume of water hits the parched, hardened topsoil left by the dry June, the physics of the soil changes. The hardened earth cannot absorb the water fast enough. Instead of soaking down to replenish the water table, the rain becomes destructive surface runoff. This is why a single violent weather event won't solve a broken seasonal cycle. One flood does not erase a seasonal deficit. Despite the current cloud cover, the IMD predicts total July rainfall will likely flatten out below the 280 millimeter average needed for a healthy season. For farmers, the whiplash is immediate. Summer crops that survived the dry June are now drowning in flooded fields, washing away the season's early work. In urban areas, the humidity spike that follows the rain drives up power demand for cooling, putting a heavy strain on infrastructure already damaged by the storms. This volatility is the new baseline. To survive future water scarcity, India must re-engineer its infrastructure to capture and store these sudden deluges before the next dry spell returns.
Subscribe for more such reports.